Today I thought I would talk a little bit more about fusion. In fact, the first cases of fusion. And in particular, I wanted to talk about how JJ Thomson produced tritium in 1913. He didn't realize that he was fusing. He was the first real case of fusion. But it was the first fully documented case. And that's documented because of his positive ray method, which was the invention of the mass spectrometer. I'll put up a picture from his paper, but basically he had a tube, he had an anode with a hole in it that would allow some of the ions to escape, and then he had magnets that would deflect the ions, and then he had photographic film that would detect the ions. And based on the amount of curvature, he could tell the ionization and the mass of what was in the gas, that what was being ionized in his Crookes tube device. And it's a very simple process, and he experimented from 1905 to 1913 when he finally published. And it was real interesting because it was the first really positive way of identifying the gases in a very rapid fashion and not have to go through a secondary identification process. So, as I said, he published in 1913, and he said in this publication that I'll put a link below where you can download it. It was published in Nature and then Science and Scientific American, and Science actually lets you download it free for a personal use copy. And I highly recommend reading through the whole thing because it's very fascinating knowing what we now know about fusion. And I'll go through some of these details. So he measured what he called X3. And now he did guess that this was helium with a weight of 3. That was one of his guesses. He didn't realize that it could have been some helium-3 that was singly ionized, but it didn't appear that he detected helium-3 that was doubly ionized. So it's probably mostly tritium. And the fascinating thing is that he produced tritium no matter what he did. He produced tritium, helium, and neon, pretty much no matter what he did. He said that he produced it from tubes filled with hydrogen, nitrogen, helium, air, and also a mixture of helium and oxygen. Although he found that oxygen has a scrubbing effect that would reduce the lines over time. And he thought that that was just hydrogen, or oxygen reacting with the hydrogen to form water, which reduced the production of tritium, which is a good, reasonable observation. And of course, the reason tritium is so important is tritium has a 12-year half-life, so it doesn't occur naturally. But he didn't realize that. He thought that it was coming from the anodes, that somehow the anodes absorbed tritium and helium and neon when they were being produced, and that when he subjected them to these high voltage from an induction coil, that it was releasing gas. Although he did some experiments at 220 volts where he showed that he could still get tritium and helium and neon at 220 volts, although he used a different anode in that experiment. And so that tells us that the arcing process is what's critical more than just the voltage. It's something about producing arcs in air or a gas at very low pressures, and Crookes tubes were normally operated at 10 to the minus 6 vacuum, or possibly a little bit lower. if you go too low in pressure, your induction coil may not be strong enough to produce an arc. So it was interesting that he produced neon, because it's one thing to start with hydrogen and get deuterium, tritium, and helium. That's a simple fusion process, although not one that we would expect based on what we're told today, that you can't get, that all deuterium and helium was produced in the Big Bang. Well, based on JJ Thomson experiments, that's not true. That's not true at all. You can produce it anywhere. Big Bang theorists tell us that this can't happen, that you only get these light elements, the hydrogen and helium, from the Big Bang. But JJ Thomson and others showed that, no, you can do it quite easily in a Crookes tube. And what that means is that all the plasma in space, if it's bright enough that it can glow where we can see it, and we see filaments of plasma all over the universe, then it should be producing helium and hydrogen. And we were also getting neon. And he wasn't the only one to see this. Ramsey and Colley had published papers even earlier saying that they saw helium and neon. And a U.S. experimenter, Clarence Skinner, said that he saw it back in 1907, in 1905 and 1907 time frame. So this is fairly common. And we can imagine that you could get helium if you add together oxygen. You can get neon if you add together oxygen with helium. But JJ Thomson found that he got more neon when there wasn't any oxygen in the tube. But of course the tube itself, the glass envelope, is filled with oxygen. Glass is oxides. So we have lots of oxygen in the glass envelope. So if a helium atom is accelerated to a very high voltage and impacts with the glass envelope, you could conceivably get neon that way if there's enough energy. And under current theories, we say, oh, there's not enough energy in that sort of reaction. But based on the experimental results, there sure is. There's plenty of energy to do that, which tells us there's a lot more possibility for low energy fusion between a number of different elements. He even said he got atomic number 10, which was boron 10, which hadn't been discovered yet. So we also have the issue that where did the hydrogen come from if you're starting with nitrogen in the tube? And what he says about that is, and I'll quote, "Though you may heat the glass of the tube to the melting point, may dry the gas in liquid air or cool charcoal, and free the gases you let into the tube as carefully as you will from hydrogen, you will still get hydrogen lines by the positive ray method, even when the bulb has been running several hours a day for nearly a year." And what he found was that hydrogen evolved naturally in a Crookes tube. It was always present. And Clarence Skinner discovered this back in 1905, and I believe it was in Physical Review where he published. So this had been known about. And so there were a number of experiments, around 20, that experimenters who had done experiments of this type and found evolution of hydrogen and deuterium and helium and neon in their Crookes tubes. And then by the early and mid-20s, they started using vacuum tubes that had a filament instead of being filled with gas, and all these phenomena stopped showing up. Although JJ Thomson also notes that he was able to use cathode rays, which are electron beams, and use targets of different metals, and he specifically mentions iron, nickel, copper, zinc, and platinum as metals from which the gases would evolve just being struck with the cathode rays, with the electron beam. So that's why he was investigating whether or not these metals contained helium and neon naturally, and tritium. Excuse me. But of course they can't contain tritium naturally because tritium has such a short life, it doesn't occur naturally. The only way to get tritium back then was to make it the way he did. So once again, he proves that there's fusion. Now, when was the first fusion? This, I say, is the first documented case because he used the positive ray method and he measured tritium, which we know had to be manufactured. Although, like I said, he felt it was evolving from the anodes because he's a conservative scientist trying to pick the most obvious answer. So Crookes, when Crookes invented the tube back in 1869, he was probably already making fusion happen. And Crookes' tube invention coincided with the mercury vacuum pump, which allowed him to get down to 10 to the minus 6. So that would be the first case where you get these high voltage, low vacuum arcs, where you're going to be reproducing these conditions. So we've probably been doing fusion since 1869, and probably been manufacturing hydrogen since 1869, and tritium, and deuterium. And also, because we're making hydrogen, that means we're making protons, electrons, and neutrons by extension when you combine the two. So there's a lot more going on in the basic Crookes tube than what you're taught in school. And that's why I say read the paper, and I'll provide some more links as well if you want to investigate further. So we really should be investigating Crookes tube fusion and the evolution of hydrogen in a Crookes tube. There's a good chance we can get energy this way and do it for far less costs than the very complicated fusion machines that are being operated. And also, once we understand how these light elements evolve, if hydrogen is being evolved continuously along with deuterium and tritium and helium, then you don't need a Big Bang to explain where it comes from. It's continuously being produced. And that supports a steady state model of the universe, which changes our cosmological leanings. Anyway, I hope you enjoyed this video, and I hope you found something to research and study more. And if you do, please like it. Be sure to share it with your physicist friends, and subscribe so you can see my next videos. And I also have my books on quantum field theory and my particle theory book. And I'm a retired independent researcher, and if you buy one of my books, that helps me in my retirement, which I appreciate. So thanks for watching.